Okay, good morning, good afternoon, wherever you may be. Welcome to this Migrating to RAD Server developer webinar. My name is Paweł Głowacki. I'm working for Embarcadero as Sales Consultant. And today I'm going to talk about the client-server development and specifically about moving your existing applications to new REST API interfaces. So as part of RAD Studio, there is a product called RAD Server. So it is separately licensed, but if you install a RAD Studio, and I'm using the latest RAD Studio 10.1 Berlin Update 2 Anniversary Edition, you have all the necessary bits for RAD Server. So RAD Server is a perfect backend for building mobile REST API powered database access services that can be used in all kinds of applications. So you can have a server and then possibly, for example, a VCL desktop application or maybe mobile FireMonkey application. So as part of RAD Studio, we also have a number of demos, and one of the demos that I'm specifically going to use today is so-called Must App or Master Application, Marine Adventure shop with selling equipment for scuba divers. So this is not a new demo. It has been used in many versions of Delphi, but it's still a nice example of relatively complex VCL application with some database access. So over time, this demo has been moved to different technologies, different database access technologies, different databases. But I'm going to use it as a, not to fully migrate it, but to see what is the structure of a similar application and what kind of challenges developers might have to move such an example, sample application. So whenever you will start do things like, for example, undertake a new project that the goal of this project is to take an existing application and create a different application or create a new application based on this application, probably the first thing you want to do is to want to understand what you are going to move. So you really want to understand, analyze your database structure, what kind of a database access technology you're using, what is the architecture of your application, and then you can really start making some decisions to create a plan how to move this application to the new desired structure. So probably the first thing you want to do is to do some refactoring. So refactoring is the process of changing the internal structure of your system without affecting how it works externally. Typically, we do it as a preparation to before things like, for example, migrating applications. So you want to have a clearly distinguished layers in your code, so it's easier to move parts of the applications to different places. And then when you have already spent some time cleaning your code, refactoring your code, you can just build your desired system and then make sure that it is properly deployed. So in case of REST APIs, we probably would typically deploy to the cloud. So this is de facto standard right now, and there are different services available for REST APIs also available in the cloud. So here I'm going to use Delphi, the latest version of Delphi, but the capabilities that I'm going to discuss are also available in a C++ builder. So on the server side, we currently, before the Godzilla launch, so right now we are in a beta period for the upcoming new version of RAD Studio with support for Linux, and then we will have a choice to build our server-side application as either Windows or Linux executables. Right now, on a server side, we are we have to use Windows, so we need to deploy to Windows boxes, and typically you would probably deploy to Windows Server boxes. On the client side, those systems, RAD server systems, can be arbitrary technology can be used. So you can use either Delphi or C++ Builder. You can use VCL desktop applications or FireMonkey multi-device applications. In fact, you can use other programming languages and tools to create clients to the RAD server systems, specifically anything that can talk HTTP and can understand JSON data structures can be used as a client to the RAD server systems. So already mentioned that RAD Studio contains RAD server. So out of the box, you have a development license of RAD server that allows you to build and test your applications. You have a deployment limit of maximum 5 users, and this is good for creating applications. So today I'm not going to focus so much on a deployment. I have spent already the previous webinar on RAD server on the topic of scalable cloud deployment. So it's not the main thing here, is rather about the architecture of the application. So RAD server is the latest capability in RAD Studio for building server or services and using the latest technology, REST APIs. So REST APIs are now de facto standard for publishing any service functionality in the web. Previously very popular were SOAP XML web services. With REST API services. The standard is relying very heavily on functionality of the HTTP protocol. So with REST APIs, we are using different HTTP verbs and using different HTTP response codes to implement business logic. So RAD server is using has much more functionality than just REST API publishing. Recently, the support for publishing server metadata based on Swagger, Swagger.io, if you go to the internet, is a very popular standard for documenting the functionality of your REST APIs. Also, when you build especially mobile applications, it's important to be able to engage your users, application users with mobile push notifications. That's something that RAD server includes. Is as easy as calling a built-in functionality of the RAD server to be able to send push notifications to either Android or Apple applications. Also, as part of RAD server, we have a user and group management. So you can, out of the box, you can create up to 5 users. You can also manage the security and privileges of these users. So you can have groups of users, and that's a very powerful thing, because when you deploy to a RAD server, you don't need to build this functionality for user management. Things like login, sign up, log out, you get out of the box. Also, part of the RAD server functionality is the usage analytics. So anytime client application makes a call to any of the published REST APIs, there is a trace in a system database. You can see who, when, and how frequently is calling which APIs. You can also do a reporting on this. And another interesting functionality with RAD server is around the Internet of Things. So we have a built-in functionality for gathering data from all kinds of sensors. There is a concept of IoT edge modules and think points that let you easily gather information coming from multiple different places, possibly not really computers, but sensors, and store them securely in a RAD server-based system. Okay, so that's a few words about RAD server and how this RAD server is structured. In fact, it is made of two layers. So there is a system database. So the very first time you run the RAD server inside Delphi, for example, or C++ Builder, there will be wizard displayed that will create for you a EMS system database. And this database is based on interface, is using FireDAC for connectivity. And out of the box, EMS already contains a lot of functionality. So on this top, in the middle of this image, you can see there's functionality like version, API, users, groups, installations, push, and edge modules. These are all built-in resources that are available through REST API calls. So this is different architectures compared to previous client-server architectures in RAD Studio. So there is the server already is pre-built. So as part of RAD Studio installation, you either get a standalone server, which is just a Windows executable that can be just run and provides the functionality that is built in. But there is also an ISAPI DLL deployment server that can be used to deploy your RAD server based backends for real in Windows IIS installation. So without recompiling the server, developers are building the functionality that they want to add to the built-in EMS functionality in the form of BPL packages. So these are special DLL libraries, special for Delphi and for C++ Builder. So you can specify through the ini file the location of those BPL files. So that's make it very easy for deployment RAD server solution. So you don't have to rebuild the whole thing. You can just gradually add or replace or provide new versions of your pluggable EMS packages. And EMS server is visible to, you can make calls using HTTP or HTTPS protocols, and any client can do. So if you are using Delphi and C++ Builder, and specifically components like TMS provider components, then you don't need to write a lot of code to get things running. If you want to integrate with some third-party tools, then you probably need to write some more code on the client to manually parse JSON and build packages, JSON data packages that the server expects. Sometimes you may see both in RAD server and in the documentation that the RAD server and EMS are mutually similar names. So the EMS is the older version of RAD server. It used to be called Enterprise Mobility Services, but still in the wizards inside of RAD Studio, we can see there is an EMS here and there. So you can think about the EMS as a subset of RAD server. It is just this very core functionality that is presented on this slide. Okay, so that's for introduction for what is RAD Studio, what kind of application we can build, and then we can have a look into an existing application and have a little review of what kind of things you may want to do to migrate your existing applications. So first of all, the technology that is being used is critical to understand how much and what kind of work you need to do to migrate your application. So first of all, we typically are now speaking about just so-called fat clients, or just single monolithic executables, Windows executables that just connects to the databases. And they can be built using different technologies. So there are big chances that if it is a Delphi older application, it's using a visual component library and so-called VCL for building the user interface. And then also historically inside of RAD Studio, there is a number of different database access technologies, different sets of components that can be used to connect to relational databases. So just out of the box, we have 5 of them. So the latest one and the one that we recommend using, the most powerful, is the FireDAC database access, but there are also other, like for example IBX, which is an interbase and Firebird set of components, DBX, the DB Express technology that was a predecessor of FireDAC, ADO, ActiveX, data objects, so different database access queries, connections, transactions that are sitting on top of the Microsoft ActiveX data objects library. And also still the BDE, the Borland database engine, is still available, but nowadays as a separate download. So if you have an existing application that needs to be moved from the BDE to newer technology, like for example FireDAC, you may want to install the BDE separately. And then it's also important where the data is stored. So you might have a Delphi or C++ builder application using, for example, I don't know, ADO components, and then the data that it is accessed is typically located on a different machine, and there are different platforms. So RAD Studio supports all major database platforms, including our own Interbase database engine, but also other popular, like for example MySQL, Oracle, SQL Server, and the like. So that's important. So when you start your analyzing your application with making a checklist of what kind of technology we are using, and also looking a little bit deeper, you may want to understand what is the structure of your application. So ideally, you would like to have clearly separated layers of code, things like very thin, as dumb as possible user interface, so just as little logic as possible embedded in your visual forms. So this could be VCL forms or maybe FireMonkey forms. And then you want to make sure that this part of application that is actually connecting to the database, all the components, FireDAC components, other components, that they are really separated from the rest of the code. So typically we do it through data modules. So just that if you have more than one data module, just one is dedicated for the data access, and it's easy to isolate and possibly replace with a different database access. And then there are other technologies that sometimes might be useful. So the typical way of building applications, database applications since Delphi 1 was with data-aware controls, when we have a visual VCL data-aware controls that through the T data source component can be connected to a different T dataset descendant components. But also it's possible to implement those things differently. Nowadays, we can use, for example, generic collections of objects that represents data that comes from the database or are being sent to the database. So all different things to understand, and the more work you put into doing your homework, it's easier to later on to migrate your application. So already mentioned that this is a typical architecture of a database application. So you have just a one monolithic application that talks to one central database. So this is when we are talking about RAD server, when we are talking about database applications, we typically talk about multi-user systems. So systems that there are many users, not just one user connecting to one central database, connecting to one central place where all the data is stored. So there are limits to such an architecture. So fat client architecture was very popular in the early days of Delphi, when client-server model was not so widely used, and it worked very well in a so-called departmental solutions, departmental applications, when you might have maybe 10 or 20 users connecting directly to the central database. So that was not enough, not so much load on a database, and it would work. However, nowadays it's just internet, and the computers are simply exploded, and it's not very practical to have all kinds of applications, maybe mobile applications running on traditional computers, on on Mac computers and all kinds of applications to connect directly to the database. So if you still try to do it and try to deploy for multiple users, you may run into problems with scalability, with your client applications not being able to connect to the heavily overloaded database. So over time, there is now more common is to use a client-server architecture, and in RAD Studio we have been using this for many years with different technologies. There was something called MIDAS, Data Snap, SOAP web services, and now RAD Server and REST API publishing is the dominating model in the world of RAD Studio. So in this model, we still have a lot of users connecting to the same data, but it's not happening directly. There is a layer in between of our application, client application, and a database, so-called service layer, and this represents a so-called multi-tier architecture, client-server architecture, which has a lot of benefits over the fat client architecture. So you can have multiple different clients. Clients do not need to maintain information about database connectivity. So clients also does not need to have the database access layer. They only need to know how to connect to the servers, and this is now typically happening over the HTTP or HTTPS protocol, which is by default, by definition, stateless, and is good for applications like mobile applications that do not expect to be connected to the database over the extended periods of time. So lots of benefits to client-server applications, and so that is the main reason why people are moving to RAD Server. So it's, if you have an existing application, VCL application that your enterprise or your company depends on, you probably don't want to throw it away, but you rather want to migrate it to this new client-server REST API architecture. So there are certain things you want to do. So after you analyze your application, you want to do some refactoring. So the key thing here is to first of all understand where is your data stored. So if the database is modern, if it's supported, if it's running on operating systems that are still viable choices. So you might need to actually also migrate the data itself. So in this example, assuming that our application is using Interbase, so maybe in the past you have made this move from the BDE and Paradox or DBase or Access flat file databases to a proper solid relational database engine like Interbase. So this may include using some external tools for migrating schema of your application and also migrating the data themselves. Also, you probably want to make sure that your database is deployed in a available, highly scalable way. So there are a new generation database services in the cloud, like for example, Amazon Relational Database Service, where you already got a lot of things out of the box, like scalability, high availability, and no need to manage your applications, and you know that it's there, and there is no problem with, for example, your main database application or machine not working. So this is a key thing, is to understand to which database and how you connect. So I'm assuming that it's available somewhere through the IP address in the internet. And then we want to work on an application itself. So the goal is to actually create a client and server application. So you want to design a REST API interfaces for accessing your data. You might want to look into the so-called CRUDL or create, read, update, delete, and list matrices for all database tables in your database to understand which data should be just for reading. Maybe you want to be able to update certain other data. So just making a list of functionality that your server application needs to provide. And then working on an application itself. So if you have an VCL application, you want to move as much logic out of the VCL forms. Maybe in the future you want to move to FireMonkey, and then you will have to do this work again. So it's a good idea to, even though you maybe don't plan to go away from VCL forms, but it's a good idea to try to remove as much code from the visual forms as possible. So before I go into some coding, here is the little diagram that I have created as part of the preparation for this presentation. So you see there are three different states. So in the state on the left side, state number 1, we have a JSON monolithic fat client application connecting through the internet to the database, and we can see if we can if we can isolate these three main layers of application code. So the user interface, so all the visual forms, data access, so all the components like data, like database connection, like queries, like data sources, data access layer, and everything else falls into a so-called app logic, which is the everything else in our application that is not a user interface and is not data access. So this is the first thing, is to actually, as part of the refactoring of your application, is to make sure that you can really relatively easily distinguish between these three layers of code in your application. And then the next step, as a preparation to the reaching the final phase number 3, where you have a client and server application, is trying to build an abstraction layer that would actually abstract away database access from the rest of your application. This is important step, and why we do it is because this database access layer is going to be on a server, and the user interface is going to be on the client. So they don't need to know about each other, and the less they know about each other, the better. So one of the good things here is using interfaces, using singleton object patterns, just to trying to take decouple as much as possible data access from the rest of the application. And then in the third state, we already have two applications, so still the user interface is ideally the same. And if we properly did the abstraction layer exercise, we could probably use the same abstraction layer in the form of some interface definitions, or the so-called plain old Delphi objects, PODOs, for exchanging data between the data access and the abstraction layer. So the moment when we are on the third stage when we have a client server applications, that we also need to add some more functionality. So the client will have its user interface and some of the application logic that is clearly part of the user interface or very close to it. And then instead of connecting to the database itself, it needs to have some classes, some components that are responsible for communicating over the internet, over the network with the server application. So here we are typically use the TMS provider component, because that's the component that is responsible for client communication with server, but also other components, like for example the REST client components can be also used to communicate with other services. And then on the server we have our data access could possibly remain intact from the previous stage, but then we need to build the whole layer of the REST API. So this, in case of RAD server, that would be the EMS packages with endpoints, so different resources and different functions that are visible to clients as endpoints. So yeah, so let's move to my virtual machine, which is already prepared, and I have a number of different projects already prepared as a part of the project group. So this is the famous master application. Let me run it. So this is also a demo that is already assuming that there was some work done on making the user interface a little bit nicer. So here we see that we are using different styles, like Windows 10 styles, and this is a main form of our application that provides access to the rest of the functionality. So that's also very good design, especially good. Actually, it's good for all kinds of applications. So when we create our application, the other forms and other data modules are not created on the startup. So we have some kind of a menu that is now providing access to different functionalities. So we can go through the different orders. So this is the typical master detail layout with two different DB grids that are connected directly to the database, data sets. So this is a typical design. We can also browse through the parts. So this is for scuba divers. So if you are diving, and myself, I have scuba diving certification, so I understand what it is, second stage regulator and regulator system, but it at the end is just a list of different parts, and there are different vendors, and we can see this is a typical application for running a shop. So you can make an order to get some more regulator systems, and with real price and discount, and this is a typical VCL application for running a shop. So this is, when you look into how this application is structured, then we see that there is this main form, and we can see in the project options there is a forms, and you can see there, this is probably not a very good design because all those forms are auto-created. Ideally, we would like to have just a main form and all other forms just created in a lazy design, a lazy way, so on the first access. So main form is our main application. So main form, here we see this is a main form, and from main form we can go into the individual forms. So you can see there's enter form, and we can go into the individual screens. So those screens are directly connected to the database. So you can see these are the different, on the previous screen we saw DB grid, but here we have a different DB aware components like TDB edits, and they are typically connected through their data source property. We see the data source. It's nice that we can still inside of the Object Inspector expand the connected component, and the data source is on a masked data. So this is a central data module that encapsulates database access logic, and we can see that this data source is connected to the customer by order data set, and we can drill further and to see different strings. Like for example, this is a select from customer SQL statement that is responsible for getting data about customers. So this is a typical layout. You can see here is this data module, and this data module contains all the database access components. So it's already some work done to clearly isolate database access from the rest of the application. So we can see here that this is using the IB database. So the database that contains this scuba shop data needs to be interbase, because that's the only technology that our IBX components can be used for. So probably one of the things we would like to do as part of this migration exercise is to actually move to FireDAC, which is the latest database access technology available in RAD Studio, and provides a lot of functionality, and first of all allows you to connect to arbitrary databases and not just to one database. So this database, you want to understand what it is, so we can actually open it in the Data Explorer, and here we have an interbase, and I have already connected the configured access in a Data Explorer to browse through different tables, so we can browse through customer data, for example, or maybe some other data, like for example vendors, to see what kind of vendors are selling different equipment to our shop. Another interesting thing that is useful to be done is to use reverse engineering. So I'm actually using the highest version of RAD Studio Architect. As of part of the installation and part of the license, you can download and install ER Studio Developer Edition. And this is the result of the reverse engineering of my database. So before I really start to look into deciding how I'm going to implement my application, it's a good idea to understand the relationship between different elements in your application. So we can see that there are customers and orders. So this is two tables connected in a master detail relationship. So for every customer that is identified by cust number field, there is a order. So there could be multiple orders. So you can see that every order has a primary field order number, but there is a foreign key customer number. So in this way, we can relate all orders that belongs to the certain customer. And similarly, we have vendors and parts, also very similarly connected. So there is one master table with all vendors, and for every record identified by vendor number, there could be a multiple parts records inside of the parts table with a foreign key vendor number. And now these two parts and orders are connected through the items table that contains two foreign keys, one to the part number and one to the order number, and represents individual row in a typical order. So there is also an employee table that connects to orders, so we can understand which employee responsible for which sale. So it's a relatively straightforward structure, and I could organize it differently. Also, when migrating applications, these tools like migrating databases, these tools can be very useful when we can, for example, create a physical model on a different platform. Another useful tool in this context is a change manager, when we could actually generate SQL scripts to migrate the actual data from one database to another. So I'm assuming that we are already good in terms of moving data, and right now I'm going to actually switch to a different database access. So as part of the initial work to move this application, I have created a very simple VCL application, just illustrating those key things. So I have a main form of my application is like a menu in my previous application. So I didn't bother to make it visually one-to-one, but when we see project options in the form, we only create a form main and not the other forms and data modules. They will be created on the first access. So this is especially important for mobile applications. That some of the main reasons why applications are sometimes rejected for App Store is because they don't start at all or start too slowly. So the less things you create on application startup, the better. So here is very simple form that just has a one button. Normally I could have more forms here, but it's just for explaining how you should structure this application. So the first moment you click on a button employees, we check in code if the reference to our form employee is not nil, and if it's not nil, then we let application create this form, and then we can just show this form. So now when the form is shown, we can actually go to the this other form, and here is the actual layout. So we are using still a DB aware components. So with DB aware components, I can use a DB grid, which is a handy component for displaying multiple records in one go, and also famous DB navigator component. And then in a typical structure, they are both connected to the database. So here I have a FireDAC connection component, and the most easy way to add this connection component is to drag those components from the from the data explorer. And also there is a sample employee table component. So this is an FD query component, and it's connected through the data source to the main form. So for those that are familiar with the BDE, this is exactly the same architecture, and it has a lot of advantages. That first of all, it's simplicity. So it's just a matter of adding a query or table component, put a data source, and then you can connect different components on the form. But FireDAC is very powerful because it has it does not try to download all the records from the underlying database. So you can still have a query component that internally has a different FD commands for updating, browsing through data, and deleting data from the underlying database. So at the surface is quite simple, but in fact it's very powerful design. So we have now, so this is example of a form that we would like to move further. So I have just employees. The moment I click on employees, I can get connected, and here are the different data. I can see if this is actually updatable. I can change this Bruce and click on apply updates, and the next time I open it, I should see that this data is already updated. So this is an updatable data set that can be used, and yeah, this is our starting point. So that's my first application, so master application 1. So just properly structured access to the data. Another interesting thing here is that you can double click on a FireDAC query, and you can test execute it from inside it. So this is really much more powerful as compared to other database access technologies that are in RAD Studio. So I would recommend that if you are not using FireDAC, that will be very high on your migration to-do list is to switch to FireDAC database access components. Okay, so now we want to do a next step. So the next step will be somehow moving to this two-tier structure. So let me show you one more time this slide. And now that we know that we have a user interface and a data access clearly separated, how do I do about separating this client and server? So the nice thing here is that you can actually, I have actually added, renamed the main data module that contains just a database connection and query components. I have renamed it to the backend, so the database data module backend. So the goal here is to have this data module to be on the server, and then another data module will be a front end. So this will be our data module layer that will reside on a client. So you still need to have on a client a data source, but now I have replaced this. I have added the FireDAC memory table component. So this is a component that I have that will represent data in my client application. So it will be just an in-memory container for the data coming from a database. And the nice trick here is that once you have an employee table, you can actually double click on it and see that it's working okay. But for keeping data inside of the memory, you would like to have also the structure. So in a next version of this iteration, we will see that I can actually do an assign data set, and that I can point it to a query component that I want this to represent, and then I can create a metadata structure of this in-memory data set that could be useful in different scenarios. So now let's try to see how we can how we can do that. I want to have a data exchange from a backend to the front end. So I know that it's going to be over the internet, over the HTTP protocol. To somehow I want to convert this data to something that can be returned from a REST API. So the easy way of doing this is to take the table. So in our case, this is a query component, and we can use its built-in save to stream method, and I can just create a string stream and return from this get employee method, that is a method on my backend, just a string with a JSON representation of my records. So this is a good approach because it's simple. So you can take arbitrary query, arbitrary data set, and easily convert it to the data set. On the front end, we do the opposite. We have a reference to the backend. So we are now have one extra layer, so that the database data module backend is behind the data module frontend. So from the perspective of our form application, that is here. When we click on connected, we just do a frontend connected, and then we also on the start of the application create the frontend if it's not yet connected. So that's the whole application code, and now our DB Grid, our DB Navigator, is not connected to the query directly, but is now connected to our in-memory table that can be used to store data. So that's an interesting design. So inside of our front end, we can take data from our backend and do the opposite. We can put this data into the stream, and there is also a corresponding to save to stream load from stream method that can be used to load data. So this is a simple design where you can take data, but the problem is that this is not updatable. You see that I have only a read-only functionality, so I can still maybe update data inside of my in-memory data set, but I do not provide a way for updating information. So the next possibility here is to look for other components that maybe make it easy to have an editable data. So the data that not only can be read, but also manipulated locally and updated. So this is another approach. I'm going to close some of those files because it's becoming quite busy here on this RAD Studio. So now I want to make sure that I'm using the right data modules. So here I'm using a different approach. Still, I have this same structure with a form main that is using data module frontend, that is in turn using data module backend. But now I want to have an updatable data. So on the backend, I'm looking at using the so-called FireDAC and JSON reflection. So this is a framework that has been introduced, I believe, in XE5, RAD Studio XE5, and it can be used to easily convert data coming from from queries. Like in my case, I have a again query component that is connected to a database table, and I can, instead of returning just plain string, I can return something called TFD JSON dataset. So that's an interesting, quite lightweight class that is designed for exchanging data. So I can return in just one go information not only from my customers, but possibly from other data sets to the client. So that has a lot of benefits, and the source code is very easy. I can take the query and open, make sure it's closed because it's going to be opened implicitly, and create an FD JSON datasets, and just using a TFD JSON dataset writer, add the JSON representation of this query to my result set. So this is better because I still have a similar approach like in the previous example that I have been using just plain streams. Now I have a more specialized class. And okay, it should work okay. So I can now also implement the corresponding method for taking the changes from my front end data module and putting the changes inside. So here is the FD-JSON deltas apply update. So this is a special class that is taking FD-JSON's deltas, so all changes from my client, and applying it to the underlying database using the command property of the query component. So this is very simple implementation, just two methods with a little code. And I have a front end here that also does not contain a lot of data, but I have a function updatable database. So we have a get customers method will take the dataset list and append it to my in-memory database. And here, when I call apply customers, I can take the delta. So if my in-memory table is still in one of the edit modes, then I'm posting the changes, so it's properly saved in the internal data structure, and I can add the delta from this in-memory table to the list of deltas. And in general, this could be more than one data set. So this is a next design, and it was probably the best way to build applications in DataSnap. You still need to connect this DB grid. I know it's not connected, so let me quickly connect this DB grid to the data source, and that should probably work. Okay, click on OK, and that should do the trick. Okay, so I'm now running this application, and I can get data, I can change something, I can apply updates, stop the application, run it one more time. Okay, it still cannot create output palette, so I need to see where it is stacked. So processes, and my application is still running somewhere. I need to just close it, but I don't see the proper task. Maybe one more time. Oh, that's maybe better. Oh, and I can get data, and I see that my changes have been applied. So we are already getting there, but the problem is that this data, we don't exchange just plain strings, but we are exchanging some higher level data. There are some additional components in this the FireDAC JSON reflection framework called interceptors that can be used to convert between data sets and strings, but this code will become more and more complicated, so it's not optimal. So the optimal design is actually a demo that I'm using the pre-built demo just to show you that you can still find it yourself. And based on this demo, I have started to migrate my master application to the server and client that you can see here. But let's have a look at the desired functionality. So there are two packages here, two projects. One is a resource package. So that's my the server side that is responsible for getting data in a master detail relationship. So very important component here is a FireDAC schema adapter. That there are two query components are pointing to this query adapter, and they using data sources. Even though we are on a server side, but these data sources are here to establish master detail relationship between orders and their customers. And yeah, this demo shows how you do it. And the source code is not very complicated. So now you see we are now in a RAD server package. So if you want to create a server, you do it through the file, new, other, and then in the EMS category, you can create an EMS package. So each EMS package can contain one or more EMS modules. So right now I have my package project open, so that's why I see the EMS module wizard. If there is no project open, there will be only EMS package visible. And I can create a package with a number of resources, and that's an result of my work. So I have a data module that is has some custom attributes, so test. I have get records and post updates. So these are the two REST APIs, one for get HTTP verb and one for post HTTP verb. The first one will get records and the second one will send updates. And again, this source code is still very straightforward, and it's very nice also because you don't have to think in terms of the individual fields, individual names of the fields. Just make sure that both your queries are open, and then the source code is quite generic. So when moving this update code to the different types, like we have here, I'm just building this, it's not finished. Hopefully it will be one day. So you can see there I have now vendors and parts table, but still this code for for example applying updates is generic. We don't really even specify in this code anything about the names of the queries. We only deal in terms of the FD schema adapter that is responsible for applying updates to the connected queries, because queries have a schema adapter property. So yeah, that's the desired architecture. And on the client side, we have a client, and the client contains, you can see this, not this client. So I'm going to open the client. So the client itself has a, maybe that's not a good design, but we have a master and detail relationship. So there are two DB grids, one DB grid connected to customers and the second one to orders. The TMS provider is a key component for connecting to our server. So I can just take my server and run it. So the server is running. So notice this is this standalone ready-made EMS development server that you can use for building your solution. So in the log, you can see a number of things that are already loaded. So those resources like version, API, users, groups, installations, push, and edge modules are built-in resources with their own API, REST APIs. And here we have our own test resource with just two methods, get records and post updates. We can open this in the server, and by default that will be a built-in version, but I can just go to test, and in test I should see the data coming from the database, but in the form of JSON. So very few lines of code to get the data converted from a specific database, and also in the master detail relationship to some JSON representation. So this has to be running, and now I can just run the second second project, and here is the also on the client very interesting component. So the EMS provider is a component responsible for making connection to the server, so you can test connect, and that's a result that is okay. And FireDAC EMS FireDAC client is a component responsible for getting data and applying updates. In fact, you will see that it's a very few lines of code. We can just do get data, we can just call post updates, and it will do the trick. So under the hood, there is a client module here, and it does not have any code at all. So it's just a few components with a schema adapter that receive data for the FireDAC client from this FireDAC EMS FireDAC client, and just use the in-memory database tables for keeping data. So this is the default the target architecture. So yeah, I can get some data, I can just scroll through the master detail, I can change some names and make a post update, and run it again to see that these changes will probably be persisted. I see there that these are the updatable master detail records. Okay, so let me jump back. We are on top of the hour, and yeah, today I have been talking about the migrating to RAD server. So there is plenty of functionality that is built in, and we have been looking through the different tasks that you need to do to properly plan your migration. So you want to analyze your code. So typically you want to move from existing fat client architecture where you have a database access logic, app logic, and user interface in just one monolithic application, and move it gradually to the client server where the functionality of your application is now split into two, and then you still have the same user interface and connecting to the same or similar database, but using a scalable REST API architecture and RAD server. Okay, so there is more information out there. There are recordings from previous RAD server webinars on YouTube, but you can also find on www.embarcadero.com. There is products, and there is a special page about RAD server. Also, there is a migration center that you can use to learn about how to move to Unicode, how to move to FireDAC, and plenty of resources. On our community, Embarcadero.com, you find answers to questions, blog posts. There will be a blog post related to this presentation on my blog, hopefully today. And DocWiki contains the latest online documentation. You can find more information. Also, as part of the preparation to this webinar, I have watched the Enterprise Mobility Services using SQL Database Access with Marco Cantu YouTube replay. That's from more than 2 years ago, but contains interesting information about using the TMS provider and the TEMS FireDAC database access. Okay, so there are also some other links to some other resources, and specifically links to Amazon, where you can actually deploy your functionality to the cloud. Let me see if there are any questions. So I'm going to go through the questions pane. So I have a question from Alf. If a query produces 1 million records, how to show only a few at a time? So that's a good question. So the queries components in FireDAC, they have a so-called a live data window. So they fetch data under the hood just to show whichever records are needed to be displayed in the grid. So for example, if you have a really 1 million real records and you jump to the end of the table in the grid, and then you will only fetch the last few records, the ones that are needed for display. And this is quite nicely documented. You can see the live data window functionality in the docwiki help. Okay, so I don't see more questions. So I hope that you have enjoyed. So I want to know there are possible migration from DataSnap server to RAD server. Oh, that's a very good question. So the DataSnap server is still a part of RAD Studio, and RAD server is a newer technology. With DataSnap server, it's more of do it yourself. So when you create a DataSnap server application, you need to build it from scratch. So RAD server is a pre-built application. So it's possible to migrate. There is no wizards, but there are similar concepts. In DataSnap, we have server methods that are just data modules that expose certain functionality to clients. In RAD server, there are resources that they also have certain resources that are exposed as REST APIs. I would suggest trying to extract from existing DataSnap database implementations the code that is responsible for dealing with a database, and keep separate the server methods unit, and just replace the server methods unit with the EMS resource that can have even identical or very similar signatures. So the difference is that in DataSnap there is a own serialization, so you can return different types from DataSnap server methods. In RAD server, the signature of a method is the same, so you need to write possibly a JSON into the response object. So that's a quite a rich topic. Maybe that's a good idea for a future webinar for the next year. Okay, thank you very much. I don't see any more questions coming. So I hope that you will have enjoyed this webinar, and I wish you a very Merry Christmas and a Happy New Year. And a lot of good coding in the coming year. Thank you very much, and enjoy your Christmas.